Hello, good day everyone. Welcome to Hi-Fi Tech Group and welcome to CCNA course ICND 1 and 2, code 200-125. My name is Irfan Haq. In our previous video, we have taken you through the course outline. Just to summarize, there are 13 sections in the new CCNA course. First three sections, they are related to 2, layer 2 technologies, which is switches, and the next three sections, they are related to layer 3, which are routers, and then IPv6 wireless, and then on chapter section 9 and 10 is about security. Section 11 is about IP services, which is VPN, and all other services, quality of service as well, and then network architecture, which is for example, cloud, data center, and the network automation is about the programming. So in this video, I will be taking you through the introduction to networking. So in late 80s, early 90s, we used to have a few companies, and they were the big player of the market, like IBM. IBM, their products, their servers, they were running their proprietary protocol. And then in 90s, there were more vendors, small vendors coming into the picture. They were deploying their own products, their own hardware, their own servers, and their own protocols. And then it was becoming challenge for companies who want to use both IBM and DEC at the same time, because both companies, they were using their own proprietary protocols. So IBM, DEC, they were not able to communicate with each other. So the developers at that time, they think of creating a central protocol, or a central protocol stack, or central framework, to which all the vendors, they should follow those standards, so that they can communicate with each other. So that's how TCP/IP came into picture. So TCP/IP, it is basically like English language at the moment. African people, they can speak to Chinese people in English. That is the common language. Otherwise, there is no way they will be able to communicate to each other. TCP/IP, it was not uh, it was not straightforward. Basically, before TCP/IP, OSI layer model, it was developed. Unfortunately, OSI layer model was not deployed. It is in the books. Theory is there for the OSI model, but no vendor adopted it. Rather, TCP/IP model, it was developed. So TCP/IP model, it is very similar to OSI model. If we see both TCP/IP model and OSI model, they have 7 layers. OSI model have 7 layers. TCP/IP have 7 layers. There are a few differences only. Here in TCP/IP model, layer 5 to 7, they have combined it into one layer, application layer. Whereas in OSI layer model, session layer is separate, presentation is separate, and application is a separate layer. So same engineer who developed OSI layer, most of them, they moved to the company who designed TCP/IP. Hence, a lot of things, they are common between OSI and TCP/IP layer model. There are 7 layers. So the first layer is physical layer, and we call bits. Physical layer media is fiber optic cable, Ethernet cable, those kinds of things. So physically, Wi-Fi, it come under the physical media as well. Then Then it comes data link layer, which is layer 2. Switches, they work on layer 2, basically switch is SW. So switch, it work on layer 2 level. And the protocol which we use on layer 2, they are like spanning tree protocol, rapid spanning tree protocol. Then the most important layer, is called network layer or layer 3. Router, they work on layer 3. And the protocol which we use is OSPF, ISIS, BGP, blah, blah, blah. So those protocol, they come under the layer 3 protocol. For a network engineer, 80% of the time, we were supposed to work on switches, which is layer 3. So, so this is basically most important layer, and roughly 80% of the time we work on this layer. Then the fourth layer is transport layer. So on transport layer, we call data unit as segment. So firewall, they work at this level as well, although they work on layer 3 plus layer 4, even on layer 7 as well. Firewall, some of the firewalls, they are capable of blocking some of the application as well. So this is the summary of the 7 layers. So layer 5 to 7 is the application layer, and we call the data unit as data on these layers. So application is, for example, YouTube, it's an application. SMTP for email, it's an application. Our uh, in the CCNA, the two most important layer that we will be focusing the most is layer 2 and layer 3, data link layer and network layer. So if we talk about the movement of packet, let's say if someone want to write an email using an application via Gmail, for example, that's an application as well. So that data, it will pass down from layer 7 to layer 5, 4, 3, 2, 1 on physical layer. Then it on physical layer, the data would go on the fiber or the Ethernet cable or via a radio link to reach the far end. So top to bottom, that's how the data moves. So on each layer, it adds an overhead, a header to the original data. For example, transport layer, it included this header. So TCP, at TCP is basically at a port number. For example, if we want to telnet something, so port number 23 would be assigned TCP port number. Then the network layer is related to router. So router, they will add a destination IP address, for example, 1.1.1.1. And then data link layer, they add a MAC address, for example, xx.xx.xs.xx, and then the data go actually to the physical layer, to the fiber optic cable or Ethernet cable or Wi-Fi. So each and every layer is adding a header to the original data. So if we see, original data is there in each and every layer, but when the data is moving down, more headers are being added to have a better control of the data. So transport layer protocol, it will add a TCP port number. Network layer, it with an IP address to guide the packet on the routers. Data link layer, it will add a MAC address to guide the to guide a frame on the switch network. So that's how data will be moved from one point to other point. So that's all for today's lecture. Please subscribe our YouTube channel and click on the bell icon button. Thank you.